Okay, Assalamualaikum and good morning to all my friends, to all viewers. Thank you for spending your time to attend this Monday Technical Talk series. Sorry for the delay. There are some technical issue at the beginning, okay, but now we have resolved. Okay, so thank you for your patience. So at first, I would like to thank to the organizer for inviting me to deliver my research work. For your information, this talk is organized by Malaysian Society for Automatic Control Engineer, or we call it MACE, IFAC Malaysia. And this event also co-organized by Center for Artificial Intelligence and Robotics, Cairo, UTMKL. The title of my talk today is about IoT devices and edge gateway provisioning, real-time analytics for simulated and virtually emulated devices. Don't worry about the title, my dear friends. To all my viewers, I will explain in detail and make it simple so that everyone can understand easily. Okay, before I proceed in my detail, let me introduce about myself. Okay, I received degree in electrical and electronic engineering from International Islamic University Malaysia, IIUM. Then I proceed my master in embedded system at University of Essex, and then I proceed my PhD at the University of Bristol, United Kingdom. Apart from that, I also a member of IEEE and a registered graduate engineer with the BEM. Currently, I'm a senior lecturer in mechatronic engineering at School of Electrical and Electronic Engineering, University of Science Malaysia Engineering Campus, Gunung Tebal. Apart from teaching, I also conduct some research, innovation, and also presenting data by publishing articles in journal. The most important thing I would like to share with you all, my research interests are embedded system, real-time control communication, and also Internet of Things. So in this research, I give more emphasis the development of the theoretical and practical method, which can be practically validated. Okay, so recently a significant research effort has been done towards industrial issues of embedded network control system and also the IoT. For those who are interested to know more about my research, you can email me to email below there. Okay, so let us back to our main topic for today. Here is the content of my presentation today. At first, I will explain the introduction of Internet of Things, Cloud, and Edge Gateway. In brief, this work or research is about gathering medical data such as temperature, blood pressure, and the ECG, which is then pushed to Microsoft Azure cloud for real-time analytics and machine learning for anomaly detection. After that, initial problem statement will be defined. When we define the problem statement, we look into the network architecture and topologies. Okay, so based on this network architecture and topologies, we also look into the what kind of environment are suited to our program. So in this case, we will investigate into simulated and emulated. After that, I will share some result and discussion, and then finally, I will make a conclusion. So far, I hope all of you can follow my presentation today. Okay, before I jump into detail, we would like to understand why do we need internet? Why? What is Internet of Things? What is internet? And then how the internet can be connected as a things, okay? So IoT devices are everywhere these days, from small scale sensors to devices such as smartphone, tablet, and industrial devices. Well, The Internet of Things, in a simple word, can be said as the network of physical objects or things embedded with electronics, software, sensor, and network connectivity, which enable this object to collect and exchange data. So it means that you can have conversation with things around you. I like to use a simple example, which is smart home. Okay, so by having your phone, so you can get connected to your fridge, maybe to your TV, and so on. So IoT allows objects to be sensed and controlled remotely across existing network infrastructure. Things, I believe that everyone love internet. Everyone love our things, our stuff, something like smartphone, our pen, pencil, and so on, our table. So things in the IoT sense, it can refer to wide variety of devices such as heart monitoring, biochip on farm animals, or any sensor devices. Okay, so all these IoT devices have few things in common, including onboard sensor, computation power, and internet connectivity. Okay, so some of these devices are not directly connected to internet, and therefore it requires at devices or gateway to gather all the information, which is then relayed to the cloud for better processing. So I hope you have some idea what is internet, what is Internet of Things, how they get connected. Based on this figure, Cisco IBSD predict that will be 25 billion devices connected to the internet by uh, 2015 and over 50 million by 2020 internet-enabled devices generating data in one form or the other. In this case, we can see, right, these devices and sensors are deployed in various domains, ranging from smart city, smart agriculture, healthcare, to industrial and military application. For better understanding, I try to give you here are some typical example of IoT devices deployed in various sector of life. They are already transforming the businesses from energy management to smart cities. Administration are already saving billions annually. Because of what? Because of the information gathered through these IoT devices. The role of the IoT in healthcare is also very significant nowadays. The global IoT healthcare market is already estimated, has already estimated at 130 billion USD and is rapidly growing. To be more specific, I try to bring all of you to look at on this figure. So we want to understand what is data provider, what is resource provider, and then how they can get connected to each other, especially for doctors, medicine, ambulance, friend, and family. So if we look at on this figure, I would like you to trigger how to get this information, how to transfer this information, and how to process this data or information, how to take the action when we receive this information. Based on this simple example, in a typical healthcare environment, we can observe on body. Here we can observe on body sensor, implant, ambient sensor, and internet enabled medical equipment. These devices, are connected to cloud using gateways. The information from these devices is pushed to the cloud. Where analytics and insight are gained through enterprise platform. The cloud interface are then used to relay the information to the health professional, for example, doctors. It is also paramount that security, privacy, and governance for medical data is met with the regulatory compliance. That is why most enterprise cloud platforms are preferred. So when we understand how they get connected, how from one point to the other point can be transferred and can be interpreted, then we would like to see how this data has been stored. Well, if you look at on this figure, we can see this is cloud computing. We can see the cloud on the left side. We can see also the cloud on the right side. If we look at on this figure, this cloud is connecting with a tablet, smartphone, laptop, and desktop, and so on. Okay, so cloud computing is not just a trendy application that people can use to store their photos and videos online. As we know, okay, we always like to access our IG photos, Facebook photo, but then where it has been stored. It is part of a business model right now that is taking in the world by storm. Cloud computing not only changes how so many businesses store and access the data, but it also changing how many of these business operate. Simply put, we can say that cloud computing is computing based on the internet. In the past, people would run application or program from software downloaded on a physical computer or server in their building. But nowadays, cloud computing allows people access to the same kind of application through the internet. Wow, this is amazing. So in this case, a simple cloud infrastructure provides storage, compute, and networking capabilities. These services are managed by the cloud provider, and therefore end user saves a lot of time and investment in managing these services. A typical cloud model is scalable, and also it can work as pay as you go model. In this case, it also very important to consider that due to constraint nature of the IoT devices, all the computation is performed normally at the cloud. Okay, so once we realize the function of the cloud computing, by saying that, we can see there are a lot of benefits of cloud computing. As I mentioned to you at the beginning, it reduces cost, increased storage, and highly automated. In this case, what I would like to emphasize, you don't have to spend huge amount of money on purchasing and maintaining the equipment. So this drastically reduce costs. You don't have to invest in hardware, facilities, utilities, or building out a large data center to grow your business. Cloud storage works like a hard disk on your system. And if you want to store any file in the cloud, it will not temper any ongoing tasks. Users can scale services to fit their needs, customize application, and access cloud services from anywhere with an internet connection. Since I'm talking about cloud and then give cloud provider, now we want to see what are the top cloud providers. Okay, there are, to be honest, there are many cloud service providers, but Amazon, Microsoft Azure, Google Cloud, and IBM Bluemix are the most prominent of all. This enterprise platform perform easy device provisioning and provide range of services needed to connect to IoT infrastructure. From this example, in this research work, we would like to focus on this platform, particularly Microsoft Azure and IBM Bluemix to gather data from IoT devices. So this is another important picture of our work for today. In a typical IoT network topology, okay, we have end nodes, okay, we have a concentrator, which is the gateway, and sensing domain, which are normally called end node, data aggregator or concentrator, that are normally called gateway, the cloud, and that store all the data and provide compute power to perform analysis on this data. As in typical IoT network, the environment can range from thousands to millions of sensor devices. Therefore, it is very important to choose a cloud provider which is able to support easy and automated device provisioning. It will also very helpful if the cloud platform provides support for edge gateway devices to gather and securely transfer the information to the cloud. Both Microsoft Azure and IBM Bluemix provide secure and easy device provisioning, which enable to onboard thousands of devices with easy. Okay, to summarize this slide, I would like to say that an Internet of Things, which is the gateway, is a physical device or software program that serves as the connection point between the cloud and controller, sensors, and intelligent devices. A gateway, okay, if you look at here, this is very important. A gateway provides a place to pre-process the data locally at the edge before sending it to the cloud. So we want to make sure what kind of link, what kind of gateway to ensure all the data that we have on the left side can be transferred and translate to specific system and the correct manner. So based on the explanation from the previous slide, I would say in the context of provisioning IoT devices to their cloud solution, provisioning is a two-part process. Okay, the first part is establishing the initial connection between the device and the IoT solution by registering the device. The second part is applying the proper configuration to the device based on the specific requirement of the solution it was registered to. Once both of those two steps have been completed, we can say that the device has been fully provisioned. Okay, so when we have a clear picture, okay, what the research about, what the issue that will discuss. So here we come to the problem statement. Okay, so the current trend, especially in IoT, is focused toward enabling IoT edge gateway as intermediary computational resource, contrary to the cloud model that perform all the heavy lifting in the cloud. It is estimated that billion of IoT devices will be deployed by year 2020, which is now. However, very little information is present on easy device provisioning. Similarly, the IoT edge-based vertical market concept has begun to surface. However, very little information is available that discuss the merits and demerits of this newly invented network architecture. Based on this issue, based on the problem that we found and we identify, this will aims to implement a healthcare domain scenario by provisioning and connecting real-time device data from simulated as well as emulated virtual IoT devices on industry-leading IoT platform. So now we come to major issue in my work. Okay, so if you look at on this figure, which is figure one, schematic flow of simulation study, you can see we have a device which is the simulated and virtually emulated device, and we also have cloud over here. Okay, so in this experiment, a typical healthcare environment is considered, where some of the vital patient stats such as temperature, blood pressure, and heart rate are monitored. In this case, MQTT protocol is one of the most widely used protocol for lightweight communication between the IoT devices. Okay, this protocol works on the principle of broker that publish topics or information at the end nodes that subscribe to it. My dear friends or viewers, in this experiment, an MQTT broker is configured to push the sensor information to both Microsoft Azure and IBM Bluemix to IoT platform. This information is then stored in the cloud storage. Okay, it will be stored in the cloud storage that is elastic and scale as the information is added. A simple web app is deployed in both of these platforms that gather the information from the storage and perform basic analytics on the sensor data. This information is then cleaned, processed, and used to train machine learning model that can detect anomalies based on the patient sensor data. So here we come to the platform. Okay, so if you look at here, we have simulation topology. In this case, we have topology A, which is direct push, and topology B, we have transparent gateway, and we look at on the topology C, we have multiple transparent gateway. Okay, so in this experiment, few network topologies are considered to observe the network latency and overall response time. We would like to understand how fast time can be respond according to different type of topologies. In topology A, okay, here in the topology A, gateway devices are completely ignored and the sensor push the data directly to the cloud. This scheme is particularly useful when all the devices have direct access to the internet or cloud and require strict compliance where patient health information needs to be securely transferred directly to the cloud. Okay, now we move to the topology B. A single edge gateway device is configured as a concentrator, okay, which aggregates all the information from the sensor and pushes the information to the cloud when its communication buffers reach a threshold. And finally, we look at on the topology C, multiple at gateway are configured that load balances the incoming MQTT traffic and pushes the information to the cloud. Based on these uh, network topologies, here we come to workflow of the resource which are required for the IoT simulation. Okay. So in this case, we can see we have two platforms, Azure IoT platform and also IBM IoT platform. So based on these two platforms, it will be connected by MQTT platform. This slide describes a typical workflow for both Microsoft Azure and IBM Bluemix platform. It is very important to know that the IBM, okay, Bluemix only provides simulated devices capability which can be programmed using Node-RED. Whereas if you look at on the left side, okay, Microsoft Azure, we can also emulate device. One such example of device emulation is a Raspberry Pi, which in this experiment were configured as a gateway. Don't worry, guys. When it comes to emulation versus simulation, emulation actually duplicate while simulation replicate a real device. Okay, so in a virtual environment, emulation imitates behavior closely. Meanwhile, simulation mimics behavior of a real device, but not necessarily match it exactly. Both are useful in application testing in addition to the real devices. So once we have set up the simulation, now we have collected the data, and then I would like to discuss on the result that we have collected. Okay, so typically temperature reading from patient, which is four cases here. We have patient number one, patient two, patient three, and patient number four. The box plot also show the mean and the variance. These values are then used to train the machine learning model. Such periodic patient sensor reading are considered important for early diagnosis or symptom that may trigger serious and escalate health condition. It is typically important for the doctors and healthcare staff to observe and monitor such pattern, okay, in on-body sensor reading for patient under observation. On the right figure, okay, if you look at on the right figure, it presents one such representation where variance and patient temperature data can be easily observed. Okay, in this scenario, if you look at on patient 1 and patient 3, patient 2 and patient 4, it is very clear that temperature reading on patient 2 and patient 4 are above normal ranges. Another interesting metric is to observe the rapid variation in reading that drift from normative condition. Such tuples can be linked to advanced analytic and machine learning model to predict the pattern and take informed decision. Okay? To give more and better understanding what I have described just now, based on the four patients here, I show to you as evidence the time series data from four cases is gathered as a training set for machine learning model. Okay? So an isolation forest-based technique is deployed to detect outliers in the data that can be thought of as irregularities. The cloud-based model helps to perform real-time light analysis on thousands of input patient data at the same time. So it's very easy. When we have the data, then we can see and then we can differentiate between normal and anomaly based on the machine learning. Apart from that, what we have collected from the data that we found, okay, based on the four patient, we also able, okay, to look at on the CPU resource utilization on Microsoft Azure. Okay, so this graph, especially on the left side, explain the CPU utilization when virtual Raspberry Pi devices are configured as gateway. On a typical Azure account, we can simultaneously run up to 20 emulated devices, each with the capability to act as a concentrator for thousands of end nodes. So this particularly CPU resource utilization, we can see it will allow easy device provisioning and scalability. And based on this info, it is possible to optimize the workload on each of the device that we have. So now we come to the next result discussion. Okay, if you look at on the left side, which is figure 6, we have message throughput versus latency based on these three topology. Okay, we have topology A, we have also topology B, and we have also topology C. All this topology has been described very detailed at the beginning of the presentation. This graph describes the network response time on different topologies. Okay? So it is clear that the direct push scheme, which is the topology A, outperform others, but it may not scale well as it in a typical production environment. Direct connectivity also increase complexity as well as the cost. Okay, so topology C, which is here, topology C with multiple at gateway perform better for increased load as the traffic is load balanced. On the other hand, the incorporation of at device in topology B witness increased latency. Not only the network response time suffer by addition of the gateway device, it also show a huge variance as the message throughput increase. Microsoft Azure provide this automatic load balancing at the edge layer, which makes it very easy from prototyping to production environment scale well. Okay, so based on this particular result, especially message throughput versus latency, we can see the throughput of MQTT message deliverable observed against overall of the latency. So based on the data that we have right now, now it comes to the end of my presentation. Okay, so in this case, I would like to make a conclusion. In this work, we look at two of the industry-leading IoT enterprise platform to study a healthcare environment scenario. Based on this work, it is observed that Microsoft Azure IoT platform provides more flexibility and easy to provision large scale of the IoT networks. It is also very important to note that the ability to create multiple consumer resource group in Azure IoT help greatly in creating service, security management, and also troubleshooting profile that can be implemented on any network size. So based on this work as well, the network latency will also able to observe to be very nominal all the simulation. Moreover, it was observed that by having an edge device may add latency and affect the overall response time of this IoT deployment. Overall, what I would like to say here, the Internet of Things is actually a pretty simple concept. Okay, a very simple concept. It means that taking all things in the world and connecting to them to the internet. So the words provisioning that I discussed at the beginning, we would like to ensure how it can be linked, how it can be gateway from one sensor to the other sensor so that it can be translate or transmit in a correct manner. Today, I believe all of us love internet, okay? So everyone love things, okay? So based on this important technology, which is the Internet of Things, is everywhere. For example, these Internet of Things in our house, our car, in wearable, in office, roads, everywhere. You can imagine, and almost every industry is moving towards the IoT implementation, automate and control their industry as well as manufacturing set. Okay, so now we come to the end. I would like to thank you very much to all viewers, my dear friends. Long time no see. Okay, but then I would like to thank for your time and attention for today's talk. Thank you very much to Mace and Cairo for inviting me. Thank you so much for your interest and attention. If you have any question, if you have more, uh, I mean, that more dump on this issue, I'm more than happy to answer. You can email me, Khairi Isha at USM mine. Okay. So before I leave, there is a very significant, a very impactful note. Okay. If you look at here, like air and drinking water, being digital will be noticed only by its absence, not its present, necklace, the property. With that, thank you very much. I hope it can give some input from all of you. Again, I would like to thank you very much and sorry for there are some technical issue at the start of my talk today. With that, thank you very much. Thank you.